Read the question carefully. So the mass of the diver with the equipment, the mass is 180 pounds divided by acceleration due to gravity, which is 32 feet per second square. Okay, the pounds divided by this g will be the mass, and let's assume the convention because everything is going downward, so downward is positive. And there are two parts of the motion. For the first part, for the first 15 seconds, okay, there is air resistance of 0.8 V, and for the second part, when the parachute is open, there is greater air resistance, that's 10 V, and the total height here is 8,000 feet. By the way, this is 8,000 feet. Now for the first part of the motion, that is given by the Newton's second law of motion, m times acceleration, m dv over dt equals weight mg minus the resistance 0.8 v. Okay, now divide both sides by m, and m is 180 over 32, which happens to be 5.625. By the way, this is 5.625, but I'm gonna write m. Divide by m and bring this v to the left side, so dv over dt, this negative positive, 0.8 divided by m v equals divided by m, this g, which happens to be 32. This is a linear in v, linear ODE in v with respect to t, so integrating factor, okay, integrating factor is e raised to this number 0.8 over m, okay, whatever that number is, dt, which is e, this is constant, t, 0.8 over mt, and we multiply both sides by this integrating factor, and the left hand side automatically becomes the derivative of the dependent variable times the integrating factor, 0.8 over mt equals g is 32 times integrating factor 0.8 over mt. Now integrate both sides with respect to t, then v times e raised to 0.8 over mt equals, integrate, so 32 divided by this number 0.8 over m, because when we integrate exponential function itself divided by this constant, so this becomes 32m over 0.8 times e raised to 0.8 over mt plus some constant of integration c. Now we divide both sides by this integrating factor so that v is isolated. V as a function of t, time t is divided by this again, so this is 32m over 0.8 plus c over this exponential function, then move that up, c times e raised to negative 0.8 over mt. Now to find this constant c, we use the initial value. So the initial velocity was 0, it was just, the guy was just dropped without any force, so v at 0 equals 0, and our position s at 0 is also 0. So we take this height as the initial height, 0, and the height here, ground, st equals 8,000, by the way. Okay, so using the initial velocity v0 equals 0, so the velocity is 0 when time is 0, so that equals 32m over 0.8 plus c times e raised to 0, because this times 0 is 0, 1, so c, that means c equals, move this over, and this is a number, by the way, okay, so that's negative 32m over 0.8. m is, by the way, 180 over 32, and this is negative 225. Now we plug this c back into this equation, thus, so the velocity at any time t for the first 15 seconds, 0 through 15 by the way, t is 32 m over 0.8. okay, that is 225 plus c is negative 225 times e raised to negative 0.8 over m t. Let me say equation 1 for this, okay, for future reference. Now if you read the question, it says find the speed, that's the absolute value of velocity of the skydiver when the parachute opens, so after 15 seconds. So we need to find the velocity after 15 seconds. So let me answer part A. V after 15 seconds is just replace t by 15, and our m is, by the way, m is 180 divided by 32, and that is 5.625. so plug in t equals 15 and use your calculator, and it comes out to be 198.35, and that's feet per second. Okay, for part B, now find the distance fallen before the parachute opens. So what is the distance in fallen in first 15 seconds? So equation 1 is the velocity, which is the rate of change of position or height. So integrate 1 with respect to time. So when we integrate velocity, we get the position or the height. So integrate 1, we get position st equals, just integrate this, so 225t minus 225 times exponential function itself divided by this constant. So 225 times negative split m over 0.8, okay, and that happens to be plus 1582 e raised to negative 0.8 t over m plus some constant of integration, let's say d. Okay, basically I integrated these two terms, and this is the case. Now use the initial velocity, initial height, and we are taking that 0. Yes, 0 equals 0. We get 0 equals, this is 0 plus e raised to 0 is 1, so 1582 plus d. That means d equals, move this over, negative 1582. Now substitute here, then we get the position at any time or height at any time for the first 15 seconds, by the way. So for equation 1, you can say this is valid for time starting 0 to 15, okay, not forever. And plug in d into here, so st, the height is 225t plus 1582 e raised to negative 0.8 over m. M is 5.625 or 180 over 32. But let's write mt plus d. D is negative 1582. That's equation 2 for future reference. And this is valid for time for the first 15 seconds. Next we want to find the distance fallen before the parachute opens. That means in first 15 seconds. Then that's part B. So yes, 15. So plug in t equals 15, and m is 5.625, and use your calculator, and it comes out to be 1980.37. that's feet. Okay, now we move to the second part, and for the second part of the motion, that starts after 15 seconds. So for the second part, just this part, the initial velocity will be initial velocity v after 15, that means v0 in this case. Initial velocity will be we found v 15 here, 198.35, and we found the distance fallen after 15 seconds. That's the initial height for the second. Yes, 0 equals 1980.37. Okay, now second part of the motion, it will be the same equation, same procedure, but the resistance not 0.8, we have now 10. So it comes down to everything similar to this. okay, and we just have to replace 0.8 by 10, okay. After 15 seconds, the motion is given by the same equation like last time. So then dv over dt plus, instead of 0.8, okay, we had 0.8, now we have 10, so 10 over m v equals g, linear in v with respect to t, so we find the integrating factor e raised to 10 over m, okay, dt, that is e raised to 10 over m t, and m happens to be 5.625, by the way. That's the mass, and we multiply both sides by the integrating factor, and the left hand side becomes the derivative of v and integrating factor, okay, so derivative of dependent variable times integrating factor, okay, that's t equals g is 32 multiplied by integrating factor 10 over mt. Integrate with respect to t, we get v times e 10 over mt equals 32 times, we divide by 10 over m, okay, then 32 times m over 10 e raised to 10 over mt plus constant of integration, let's say e, because c and d are used, you can write c. Now we divide both sides by integrating factor, then v as a function of t, or just v, equals, divide this, and this becomes 32 times m over 10, that's 18, okay, plus e, and we are dividing by this, so e raised to negative 10 over m t. Now we use the initial velocity for the second part. So for the second part, the initial velocity, that means the velocity after 15 seconds, okay, v0 was 198.35, that implies this is 198.35 equals 18 plus e times e raised to 0, which is 1, so it's e, so the constant e is 180.35. Now back substitute here, so for the second part of the velocity after 15 seconds, v is given by 18 plus e is 180.35, we just found here, times e raised to negative 10 over mt, equation 3, and this is true for t bigger than or equal to 15 seconds, but we reset that clock and we set v0, so let's not write anything, and this is the second part after 15 seconds. And from this we can answer part C, the terminal velocity. Read the question, go back and read the question. VL, that means limit of this velocity, limiting velocity when time goes to infinity. When time is very, very, very large, what is the velocity? So that means find the limit of this function when t goes to infinity. 18 is 18 plus e, look, this number times e raised to very big, e raised to negative infinity. And e raised to negative very big is very small, that's 0. So pretty much this limit is 0 when t goes to infinity. Okay, because this exponential function on the bottom, e raised to 10 over mt. And when t goes to infinity, this exponential on the bottom goes to infinity, and something over infinity is 0. So basically 18 feet per second. Okay, that's the limiting velocity. To answer the last question, now we integrate 3, equation 3, and that gives us the position or the height. So integrate 3, we get the position equals 18t, and integrate this. Okay, when you integrate this, you get negative 101.45 e raised to negative 10 over mt plus some constant of integration f. And now to find f, we use the initial height using s0 equals 1980.37. that was found on the end of the first part. We get this is 1980.37 equals 18 times 0, e raised to 0 is 1, so negative 101.45 plus f, that gives f equals 2081.82. Substitute back here, then we get the height for the second part. At any time the distance traveled or the position of the height is 18t minus 101.45 e raised to negative 10 over mt plus 2081.82, equation 4. Okay, now if we go up and let's read the question. The part D was determine how long the skydiver is in the air after the parachute opens. So after opening, that's the second part, how long he is in the ground, okay, after the parachute opens. So from here, on ground means the height was 8,000, so we set the height equals 8,000 and solve for t, and that's the time for the diver stays on the air. Okay, so setting the height equals 8,000, that's on the ground, so 8,000 equals 18t minus 101.45 e raised to negative 10 over mass was 5.625 by the way, t plus 2081.82. Now let's put the exponential function alone and others on the other side. So bring this to the left side, move this to the right. So this negative, that's on the left side. So 101.45 e raised to negative 10 over 5.625 t equals, that's 18t plus 2081 minus 8,000, and that's negative 5,918.18. Okay, to solve this is an exponential equation, this is a linear equation. Okay, let's divide by 18. Divide by 18, divided by 18. Then this is 5.64 times e raised to negative 10 over 5.625 t equals divided by 18, so this is 1t. Divide by 18, you get 328.8. Now graph this part in your calculator and graph this part and find the point of intersection, and that's the x value, which is t value here. But when t is very very big, e raised to very big number, because this is bigger than 1, and times t very big means very small. Okay, after some time this part becomes very very close to 0. If you graph, okay, it just becomes very very close to 0 quickly. Never goes to 0, but very very close to 0. And if you graph this t minus something, that's like t minus number, and that's it goes here. So this becomes very very close to 0, and this is 0 at 328.8. So they intersect, these two graphs intersect, by the way, very very close to 328.8. so the time, the required time, that's our answer by the way, part D, is 328.8. You can check from the graph, but this is should be clear, because this becomes very very close to 0 quickly, and this is 0 at 328.8. so basically they intersect very very close to 0 line, this 0 level. So the x value, which is t in our case, is 328.8 seconds. Final.